January 2019, number 29. Given points A, B, and C, use a compass and straight edge to construct point D so that ABCD is a parallelogram. Leave all construction marks. That's always the instruction for constructions. You need to leave all marks, never erase anything that you do. Okay, the key to this construction was this. I can remember many of the mistakes some people made. So I'm just going to put a little parallelogram here on the side just to show you a little scrap. They are very particular in naming this parallelogram A, B, C, D, right? The name of a parallelogram are the four vertices of the parallelogram, and they need to be in that exact order. So if we call, any given point, say down here, similar to the one we have to do here, point A, B, C, and D need to be either clockwise or counterclockwise. We cannot crisscross those, or this will be an incorrect construction. So if we look down below, they have A over here and B over here and C over here, which means D needs to be up here between the A and the C. I can remember that some students, if you look down below, put the D over here in this area, and that would make it parallelogram ABDCA. Or some other students put their D down over here, and that would make it parallelogram ADBC. So I guess the most important thing to remember as we begin this construction is that D will need to be in this general area over here. Okay, so let's take out my compass, and I'm just going to use straight lines on the smartboard for the straight edge. So once you know where D needs to be, we could actually begin this construction by connecting A to B. Don't think it's a little off. I'll pick that up. And connecting B to C. Right? Now, if we understand the properties of a parallelogram, we know that AD will need to be congruent to BC because the opposite sides of a parallelogram are congruent. So I'm going to come down with my compass and measure A, B, C. And once I have BC measured, make sure it's locked in and tight on my compass, I'm just going to bring the pointer of B over to A and draw a nice arc in the general area where I know D will be, because all of those points are equidistant to A and the exact measure of BC. Now, we also know that the other opposite pair of sides are congruent, right? If we look up at that other parallelogram, that means that AB will eventually be congruent to CD. So I'm going to bring my compass now down once again and measure BA, or AB. And then I'm just going to carry the pointer over to C and intersect the arc that I just made. That point of intersection is what we're looking for. I'll emphasize it right here. I'll call that point D, and then finish off my parallelogram by drawing with my straight edge from C to D and from D back to A. We now have parallelogram A, B, C, D. August 2018, number 25. In the circle below, AB is a chord. Using a compass and straight edge, construct the diameter of the circle. Leave all construction marks. Well, here we must remember that any chord in a circle that is perpendicularly bisected will either be a radius or twice the radius, which is the diameter. So this question was just a fancy way of asking, construct the perpendicular bisector of AB. And that is a construction we've been doing for quite a while. So let's get to it. So I'm just going to take my compass. I'm going to put it on one of the endpoints of the chord. I'm going to open up again to what's obviously more than halfway to be, right? If we don't go more than halfway, we won't have intersecting circles or arcs, and that's the most important part of a construction. Now, I'm going to be a little bit of a minimalist in this one, so I'm just going to go above the chord and draw that arc and below. And then I'm just going to, with the same exact radius set to the compass, go to the other end and make sure I intersect both of those arcs, both above and below. Our key is always to have 2 points of intersection so we can put our straight edge in. I'll emphasize them. There's one point of intersection. There's the other. So basically, at this point, all you need to do is to put your straight edge down on those 2 points and make sure they go through the whole entire circle. Now I'm going to go from there over to the other side. Now, once I've done that, I am going to go back and reread the instruction, make sure they didn't want me to label anything, because that's the most important part of a construction, that you complete it in exactly the way they're asking. They don't ask me to label anything. So, one thing that you could do, I, on the smartboard, need to, connect those 2 points, but if you had your straight edge down, you would only need to draw the part of that which begins and ends on the circle. And now if you wanted to be fancy about this, you could say, well, this little part right here is congruent to that right there, and this angle right here is a right angle, because you just did the perpendicular bisector of a chord. June 18, number 29. Using a compass and straight edge, construct the median to side AC in triangle ABC below. Leave all construction marks, of course. Okay, median. I like to remember that a median kind of sounds like the word medium, and medium is always in the middle. So the median of a triangle is really a line segment that goes from one of the vertices of the triangle to the opposite side's midpoint, the middle of that side. So the first part of this construction is finding the midpoint of the side we're drawing the median to. And here it's very particular. It says a median to side AC. I can remember that many students on this construction did this properly, however, to one of the other sides and lost one of the points. So I am going to begin this construction by finding the midpoint of AC. Now, finding the midpoint is very similar to doing the perpendicular bisector. I'm going to go to one of the sides, more than halfway to A, right? That's side AC. I'm going to draw an arc both above and below that side, and with the same exact radius, I'm going to intersect that on both sides. I know some of you like to draw the whole entire circles when you're doing constructions. That's absolutely fine. Now, since I'm only finding the midpoint, when I'm doing this on a smartboard, if I'm not actually drawing the line, but it's just my straight edge, I'm going to use a dotted line. So I'm going to go from one of those points of intersection to the other. Imagine that that's my straight edge. And I'm going to mark the midpoint of AC, which is right there. Now, once you have the midpoint of AC, remember we were drawing a median. A median is a line segment that goes from the midpoint of one of the sides to the opposite vertex, right there. That right there is a median. And one thing we know is true about a meeting is that this little part over here should be congruent to this little part right there. January 18, number 26. The diagram below shows circle O with diameter AB. Using a compass and straightedge, construct a square that is inscribed in circle O. Leave all construction marks. Well, inscribing any figure inside a circle means that all of the vertices of that figure should be on the circumference of the circle. Another thing that you could remember about inscribing certain figures is if you know that a square has 4 sides and 4 vertices, we're also basically dividing the circle, which has 360 degrees, into 4 equal arcs. And most of you know that 360 divided by 4 is 90 degrees. So basically what we're going to be doing here is finding 2 other points on that circle. If AB is a diameter, the arc AB is 180 degrees. So once you have one diameter of a circle, all you really need to do to finish the construction part of inscribing a square is to create a perpendicular diameter to the one that's given. So that's easy enough. So I'm going to take out my compass and put it onto point A. And I'm going to open it up more than halfway. Now, all diameters go through the center of the circle. So I really don't need to have 2 points of intersection because I already have one, which is the center of the circle. So I really, at this point, just need to go above the circle and draw an arc, and then go over to B with the same exact radius set and intersect that. I now have the 2 points I need to create my perpendicular diameter. So I'm going to put my straight edge on the center of the circle and go straight up through there. And then I'm going to, so I'm on the smart board, it's a little different for me, I'm going to extend it down there. And that right there is a perpendicular diameter. And now I have divided my circle into 1, 2, 3, 4 equal parts. So all of those arcs there are 90 degrees. And it says construct the square. It doesn't say I have to name it. So I'm just going to go to my straight edge once again and connect all the points. So there's 1, 2, 3, 4 sides. And that is an inscribed square to circle up. Use a compass and straight edge. August 17, number 28. Using a compass and straight edge, construct a regular hexagon inscribed in circle O. Leave all construction marks. Well, of course, you need to know that a hexagon has an n of 6. So it's a 6-sided figure. Because it's regular, it's basically saying that all of the sides and angles are congruent. Similar to the square, we could, if you wanted to, on your side of your paper, you could say, well, basically I'm dividing 360 degrees into 6, which means you're trying to figure out a way to divide the circle into 6 60-degree arcs. Well, there's many ways that we can go about this. So let me do the one that we started the year with, right? And that was the flower, right? So if you could just take a compass and put the pointer on the center, since they gave us the center, and open that up to any point on the circle. Right? Once you have the radius of a circle set in your compass, you can then go to any point on the circle. So I'm going to start right up here. Go to any point on the circle with the radius and start creating circles that all go through the center of the circle. And now that circle created 2 points of intersection on the circle. So now I'm going to go to each one and draw another circle that goes through the center of the circle. And then I'm going to go to this one. Let's see, it's creating this flower. I'm going to go over to this one. Sometimes it doesn't work so great on the smartboard because it's not that accurate. I'm doing my best here. Oh yeah, this is not a very good one. Okay. Got one more. See how that one came off the circle? It's not very good, so I'm just going to cheat a little bit. Okay, so as you can see, sometimes on the smartboard this doesn't work out very well because it's not perfectly accurate. But you could see that I successfully divided the circle. I'm going to see where that one's a little off circle. I'm just going to draw nice big points. This one's really off, so I'm going to put it right in there. You know, it's good enough. Your pencil compass will work better than that. So I basically have divided the circle into 6 equal arcs, so I can now connect them. There's 1, 2, 3, 4, 5, 6. And there is my hexagon, and they didn't give any other instruction. Now that would be someone who's the opposite of a minimalist. That would be a maximalist, if that's a word. So I'm going to go backwards, and I'm going to do this again in a minimalist way, because once you get good at constructions, you don't really need to do all the work. So let's just go in reverse and show you kind of a minimalist way. You know, once you have that radius set in your compass, all you really need to do is to, is to put the compass on any point on the circle and just do that one little intersection, right? And then go to that point and just go around the circle. And that should work out every time. Put this one back to that one where I started. And go to this one. Flip it around and get that one. That's all you really need to do. There we also, that's the minimalist approach. And then connect 1, 2, 3, 4, 5, 6. And there's your hexagon. June 17, number 25. Ooh, getting a little fancy here. Given trapezoid JKLM with JK parallel to ML. Using a compass and straight edge, construct the altitude from vertex J to side ML. Leave all construction marks. Okay, so in this case, there's a given that JK is parallel to ML. I guess that was important because if you only have one pair of opposite sides of a trapezoid that are parallel, the altitude would need to be a line segment that connects those two bases, base 1 and base 2, and is perpendicular to both of them. And the only way that it's going to be perpendicular to both of them if they are parallel. So that makes sense. So basically, they are asking us to drop down a perpendicular height and altitude from J to LM. Now, sometimes when you have to do this construction, it's helpful to just put your straight edge down on the base that you're drawing the altitude to and just extend it. You can always extend lines to help you out in constructions, and you'll see why that's important. Let me put that right on there. Okay, so let's begin. I'm going to come down here. All right. So the construction begins by putting the pointer on the point where we're dropping the altitude from, and opening up your compass to a radius that will intersect the base twice. So you kind of have to experiment with this one. This is kind of why I extended that base. So now if it was too small, I would be able to make it extend past, and that would be fine as well. I'll do that since I already extended it, right? So once you have a comfortable arc that you know is going to intersect that base at two different places, you could draw it. Boom, boom. And you can see we now have 2 points of intersection on the base. One all the way out here and one here. Okay, so we're going to use those now. I'm going to drop the compass down and put the pointer on one of them. Just make sure I'm open to more than halfway to the other, as usual, because we need to have that point of intersection. You can see I am. Then I'm just going to draw an arc down here and go to the other point of intersection and intersect that arc. I now have the 2 points I need to drop down on altitude. Point J, which was stated, and the point of intersection down here below here. So I'm going to now put my straight edge on both of those, and I'm going to start at J, and I'm just going to stop. You could draw it all the way through, and that's fine, but I'm going to bring it up here and stop because there's my altitude, and an altitude is a line, is a height which is perpendicular to the base. So I'm going to put my little right angle in there too. There's my altitude, which is often represented by the letter H. Height. Okay. January 17, number 25. Using a compass and straight edge, construct the line of reflection over which triangle RST reflects onto triangle R prime S prime T prime. Leave all construction marks. Okay, in this construction, it's important to know something about a line reflection. When you reflect a figure over a line, there's a couple things that are true. First of all, the original point, say point R, and its prime, R prime, will be equidistant to the line of reflection, like looking at yourself in a mirror. Another thing that is true, that if you had an imaginary line connecting R to R prime, that line would be perfectly perpendicular to that line of reflection in which they are both equidistant to. So to simplify this, you could choose any pair of original points and its prime. So I see that R and R prime are the closest, so I'm going to use those. And I'm going to reverse engineer exactly what I just stated. I'm going to draw an imaginary line that connects them, so I'll put my straight edge down on R and R prime and connect them. And once I have that line, all I need to do is construct the perpendicular bisector of that line, and that will be my line of reflection. So I'm going to take out my compass, make it red. My compass. And put it on, say, R prime. All I have to do is make sure I am more than halfway to R. Again, you could draw the whole entire circles or just the arc above and below. Move the compass to the other end and again intersect those lines both above and below. And once you have that, all you need to do is to put your straight edge on the 2 points of intersection, and that right there is your line of reflection. It does not say to label it in any particular way. That's it. You can see it works out nicely. If you look at that picture, you can see, yeah, that is the line of reflection. And again, I could have used any pair. I could have used TT prime or SS prime. It would be the same exact line. Okay, January 2017, number 33. Using a compass and straight edge, construct a regular hexagon. We just did one of those. We're going to do that again. Inscribed in circle O below. And this time they want us to label it A, B, C, D, E, F. You might notice this is question 33. So this is a construction which is a little bit rarer than the others in that it's a 4-point question. There's another question on the bottom, another part of it once we finish that. If chords FB and FC are drawn, which type of triangle, according to its angles, would triangle FBCB? Explain your answer. So this is a 4-pointer, right? 2 points probably for the correct construction and label, and then another 2 points for the bottom. I'm going to guess that that's true. All right, so here we go. Let's do the hexagon. We've already done this, so I'm going to do this a little bit quicker than we did before. Again, they give us the center. That's important because with the center, we need to be able to measure out the radius, right? And I can't, with the smartboard, it's a little bit harder to get it exact. All right, so now I'm going to put a starting point. I'm going to put a starting point somewhere on the circle, put it, say, over here, and move my pointer there, and again, just go around the circle. I'm going to be a little bit of a minimalist here, so I'm just going to go around the circle with the radius set. Just doing the intersection. Remember, we could do the whole flower. Some of you like to make the whole flowers. If you want to be a little bit more artistic than I am being, you can certainly do the whole entire flower. It is very pretty. I do like pretty constructions. And here's my, I can see how I did it last. You can see how it's off a little bit, but that's okay. So here we go. I'm going to connect now. There's 1, 2, 3, 4, 5, 6. You can see it's a little bit off, but that's okay. That's just the smartboard. Label it A, B, C, D, E, F, right? Whenever you're labeling any polygon, you can really start the A anywhere you like. But then the B, C, D, E, F do need to be in order, either clockwise or counterclockwise, never crisscrossing. So I'm going to go around clockwise. So A, that'll be B, that'll be C, that'll be D, that'll be E, and this will be F. Okay, so that's 2 points right there. So let's continue on to the second part. It says, if chords FB and FC are drawn, you know what? I'm going to draw them. I'll change the color, I'll make them a little bit brighter. So if chords FB, so from F, B, and F, C, should be around there. I know it looks like it's a little bit off, but are drawn, what type of triangle would FBC? I'll use my little tool here, my irregular pentagon tool, just so you could see that triangle a little bit better. So F, C, B, right? And I'll take that, and I'll use my properties tool to bring down a little bit there so you can see it. Yeah, so there's that triangle. So what type of triangle would that be? Well, here we have to use some of our knowledge about inscribed angles to a circle. And since that is an inscribed triangle, all 3 angles are inscribed to the circle. Now, we also need to remember that since this was a hexagon, which is 360 degrees divided into 6 equal parts, each of those arcs is 60 degrees. So that means that this arc over here, arc BC, is a 60-degree arc. And which means that angle BFC is an inscribed angle. And you might remember that inscribed angles are in a 1-to-2 ratio. to the arc, which means this angle down here has to be a 30-degree angle, which is 1/2 of 60. Now, if we go over here to angle FCB, that is going to be an inscribed angle to this whole entire arc over here, which is 60 plus 60, which is 120. And half of 120 is 60 degrees. Now, of course, we could figure out the last angle just by adding 30 plus 60, which is 90, and subtracting from 180, which is 90, or we can use the exact same method that we used for the others. This last angle is also an inscribed angle. It's actually an inscribed angle to an entire semicircle, or 3 of those 60-degree arcs, which is 180, and half of 180 is 90. So we could see right now that there are many ways we can describe this triangle. Well, one, you could say it's a, you can say triangle FBC is a 30, 60, 90 triangle. That would make it a scalene right triangle. And explain your answer. Well, the explanation would be exactly what I have just talked about, the inscribed angle, right? So your explanation would be explaining how each of those angles is inscribed. That angle BFC is equal to 1/2 of arc BC, which would make it equal to 30 degrees. That angle BCF is equal to 1/2 of arc FAB, which would make it equal to 60 degrees. And that the measure angle FBC is equal to 1/2 of you can write even a semicircle, right? Which is equal to 90 degrees. It's more than enough work to get full credit for this problem. August 2016, number 28. In the diagram of triangle ABC shown below, use a compass and straight edge to construct the median 2AB. Okay, we had this problem before, so it's a repeat. So it says 2AB. So again, we need to find the midpoint of AB. How about I'll do the whole circles? I know some of you are whole circle people. So make sure you're more than halfway to B. Draw circle A, right? Remember, circles are named by the point that is their center. Circle B, right? You see those 2 points of intersection. I'm just going to drop down a dotted line because what I'm really interested in is the midpoint, right? And then a median is a line segment from the opposite vertex to the midpoint. That line right there is the median to side AB. That's what they asked. It is. Okay, here's another part 3 construction with 2 questions. August 16, number 32. Using a compass and straight edge, construct and label triangle A prime, B prime, C prime, the image of triangle ABC after dilation with a scale factor of 2 and centered at B. Leave all construction marks. And you can see at the end of this problem, there's another part, describe the relationship between the lengths of AC and A prime, C prime. Okay, well, let's first do the dilation of 2, right? Sometimes we write this out as a D subscript 2. and we are working that on triangle ABC. Well, it's important to know the point that it's centered about. And here, point B. So starting from point B, to do a scale factor of 2, this means we're going to double the length of all the sides from B. So the first thing that we would do here is put down our straight edge on B and extend it through, in this case, C. I'll do one at a time here. I'm just going to fix that because this marker is a little off. And a scale factor of 2 is really quite simple because all you really need to do is to measure the distance of, I'll work it up here, to measure the distance of BC with your compass. And if you put the pointer on C, then all you really need to do once you measured BC is just to flip it around and intersect that line. And that right there is your C prime. And it's kind of obvious that C prime is twice as far from B as C was. That's a dilation of 2. So now we're going to do the same process with BA. So I'm going to really create a ray B through A. Always make the line much longer than is necessary. I could see how long BA is, so I make this much longer than I need. And then I'm going to do the same exact thing that I just did. I'm going to put the pointer on A, right, and measure the distance to B. I do it in that direction because then all I got to do is flip my compass around and intersect that line, and that is going to be my A prime. And to finish the triangle, all we need to do now is connect A prime to C prime. So we now have triangle A prime, B prime. B and B prime are the same point, C prime, which is the dilation scale factor of 2. Now, the second part of this question says, describe the relationship between the lengths of AC and A prime, C prime. Well, it's very easy to remember that whatever the scale factor of a dilation is, the lengths of the new triangle will be exactly in that ratio. So a scale factor of 2 really means that all the sides of the new triangle will be twice as long as their original. So one thing that we could write about the relationship is that AC and, or I can even write it better by saying side AC to A prime C prime is a 1 to 2. Remember, I'm putting the 1 relates to the AC and the 2 because that's twice is a 1 to 2 ratio. Now, another thing that we know here is that dilations preserve angle measure, which means that angle BCA has to be congruent to angle BC prime A prime. And it means that angle BAC is going to be congruent to BA prime C prime. And of course, angle B is congruent to angle B, reflexive property. Now, the only way that those angles are going to be congruent is if they are formed by 2 parallel lines, because those are corresponding angles. So another thing that we know is true about those two, AC and A prime C prime, is that AC is parallel to A prime C prime. And there you have it, 10 constructions from 10 Regents.